Good day to you and welcome to the solution video of the intermediate puzzle The Pentagon Offspring, published March 27th of 2024. And it shows three regular pentagons like this. There is a large green one and there are two congruent yellow ones, and these share a vertex and a side, and also drawn are three line segments, and the question is to prove that those three line segments are concurrent, so go through the same point. Well, this is a rather tricky one, so what we'll do is I will draw some line, I will extend some sides. So first of all, let's make visible the vertices like this, and I'll extend this side from A to E, and I'll draw this line, and it is from some simple angle chasing. It's very easy to show that those two lines are in fact parallel, and that's very important for our proof. I'll also extend this line. Now, let's say that the large pentagon has side length 1 and the two small ones have side length x, like that. Well, what we know, and that is a well-known fact, is that this triangle from the intersection here, there is an angle 36 degrees, and it's isoscalous, and this is known as a golden triangle. And what is known is that this base has length 1, then it is known that this side of those two sides have length phi, which is the golden ratio, like this. So this one also had length phi. But this is a well-known fact from pentagons, a lot of golden ratios in there. Well, then what also we have here, this same angle, and we'll again draw this line, and here again we have a smaller golden triangle. So what we have here, we had x, so we have here the length x phi, so x phi over there. Now we can then draw a parallel line, let's say from draw a parallel line to this side from here. So we have here a parallelogram, because this one is parallel to that one, this one is parallel to that one. So this x phi transverse is also here, and it is also over here. And mind you that this one is also x phi. We know that in the small pentagons. So it is known that the diagonals in the pentagon are to the side as phi to 1. So we know also there is an x phi. So we have those two lengths. And finally, if you look at this triangle, we have here the length x. And if you do some angle chasing, you will find that here we have 36 degrees. So this is isoscalous. So that means that this length is also x. So that's a lot of finding length, but now we are where we want to be, because we'll compare, we know that those two lines are parallel, so if we compare these two triangles, they are similar. So we know they have a proportion of 1 to x phi, so that we know that 1 to x phi is the similarity of those two triangles. So they intersect, and that means that the intersection also is at 1 to x phi. But now we compare this triangle from there to this triangle, which are also similar because again the bases are parallel, but their bases, they are from they have the proportion of phi on the left side, so phi, and on the right side we have x phi plus x, so we have x times phi plus 1. So that's those two. But if you calculate, if you divide left and right with phi, you will find that those two proportions are exactly the same. So phi to phi plus 1 is exactly the same as 1 to phi. But that means that they separate exactly the same, and therefore the two intersection points are on the same place, and therefore they are concurrent. And that completes the proof of Pentagon offspring.